Hello, this is a video going over examples from Math 1530 section 2.2 homework. So as you can see right here, this is dealing with a particular problem with number 1. Hopefully you can read it very carefully, and it says describes the range of results for the correlation coefficient. I'm going to be going back and forth between a lot of different pages, so please bear with me for the explanation for each one. So for this one, let me zoom in and out. First thing you need to understand, what is a correlation coefficient? Now the correlation coefficient is a value that measures the relationship between two different variables. And I notice that I have a typo right there. But again, it is the measure between two variables. It's actually measuring the relationship. For example, the number of hours one may sleep could be represented by the variable x. And the energy level one may have may be represented by the variable y. So the correlation would be the more you sleep, the more energy you should have. So this would be a representation of a positive correlation. Hence, it would be close to a whole number 1. Another example is the less education required for a particular job. That means the salary or the pay of the job is actually going to be affected in some form or fashion. That's another example of a relationship. So the more education one's supposed to have, the more money you're supposed to get paid. Correlation itself falls between 1 and negative 1. It would never be 0 because that would not include an actual relationship. So going back to the first one that we saw, again, let me zoom in. The correct answer choice is C. The range of values for the correlation coefficient is negative 1 to 1 with the word inclusive, meaning that it includes negative 1 and positive 1. Now before we move on to number 2, as you can see, let me give you a visual representation of what correlation looks like. And again, my apologies for the back and forth between the different slides because this is a live video. And hopefully you'll be able to see everything with my bright yellow fingernail polish. So graphs of correlation, again, the correlation measures the relationship between variables. If it's a negative relationship, notice how the linear equation is going downward, and therefore the correlation coefficient will be close to negative 1. If the relationship is positive, notice how it's going upward from left to right. That would be a positive relationship, which means that the correlation coefficient would be close to positive 1. When there is no correlation, it's just going to be data all around the place. So that's what those dots represent, data plots. This is no correlation because it can be horizontal, it can be negative, going downward, and it also can be positive. The correlation coefficient is always represented by R when you're using your graphing calculator. That leads to our second problem. And hopefully you can actually see those numbers. This is a good time to pause the video and get your TI-83 or TI-84 graphing calculator available. And what the problem states, it says that the data below are the temperatures on randomly chosen days during a summer class and the number of absences. Calculate the correlation coefficient. So one of the things that we're actually going to do is determine what your values are. So your X values are going to go under list 1, and your Y values are going to go under list 2. So we're going to use our calculator to find R. Well, one of the things that we're going to do, I'm going to get this out the way, and I'm going to come back to it shortly, is once you cut your calculator on, hit your stat key, hit enter for edit. Notice how you have the values for your X values or in the table or from the table in L1, and the Y values from the table are in L2. Once you've entered the numbers in, hit stat. Use your right arrow key to go to calculate. Hit enter for one variable stats. Notice how mine is an older version of, or newer version of the calculator. So older versions, my apologies for the tongue twisters, should have L1 there. So I'm going to hit clear, then hit my second key, then the number 1. Those of you with a different model of the calculator, you should see one variable stats across your calculator and just hit enter. Those who have one that looks like mine, make sure that your frequency list is empty. Go down to calculate, hit enter. So we've done this before. That's to find your mean. But remember, we're looking for a correlation coefficient. You may remember some of these steps. Next, we're going to hit Stat. Go to Calculate. Now, the one variable stats is just to emphasize that you're using two different lists. So, notice how we're looking for linear regression because that was the illustration that we used earlier. So rather than using the one variable stats that I just showed you, go down. Again, hope you see the yellow fingernail polish. Go to linear regression. Hit Enter. Notice how both lists automatically appear. Now those of you who have an older calculator, you simply hit Enter. None of this will show. But if yours looks like mine, make sure you see L1 and L2. Again, if you have an older version of this calculator, such as a TI-83, you just see linear regression. Just hit Enter. Those who have one similar to my calculator, go to Calculate, hit Enter, and there we go. You're looking for the correlation coefficient, which is represented by R. That's 0.98. Going back to the actual problem, here we go. The answer choice is B. Make sure you pay close attention to what values you're supposed to round to. Moving on, let's look at number 3. Notice how you have two data sets, data A and data B. Data A has a coefficient of negative 0.991. Data B has a coefficient of 0.991. Notice how the answer is C, saying that both data A and data B are the same strength in linear correlation. So go into a different slide. Hopefully you can see the different colors and it's clear. Again, data A is negative, data B is positive. But if I took the absolute value of each one of these, that's what these two bars stand for. Notice how one negative and one is positive. Absolute value simply means it's the value measures the distance from 0. So both of these correlations are the same. One is going to be 0.991 units to the left of 0 because it's negative. Think about a number line. And then the second one is 0.999 units right of 0. So again, think about a number line. Here's your next example. So you might want to pause it just for a minute before I get into more details and write down the definitions of causation and correlation. Correlation, again, stated earlier, is the relationship between two variables or the measure between two variables. Causation variables are variables that allow an event to occur. For example, if you do not put money in a ticket or get money in a, what's those things called? Parking meter. Obviously, you know I don't drive a lot. But if you don't put money in a parking meter, the result is going to be you getting a ticket. Therefore, you got a ticket because you didn't put money in the meter. The relationship is going to be the measurement. I would say that would be a negative relationship because nobody ever wants to pay for a ticket. So let's go back to the problem. And hopefully you can see all of that. So let me cover this up so you won't get too confused by reading too much. So when you're seeing this, notice how the fact that two variables are strongly correlated does not itself imply a cause and effect relationship between the variables. Think about the relationship I just said. If you didn't put money in the meter, you're supposed to get a ticket. However, that does not necessarily mean true. What if you were parking downtown during the weekend? You don't have to put money in the meter. Therefore, you won't get a ticket. Here's another example. And before I show you the rest of it, make sure you read carefully what your explanatory variable is and what your response variable is. An easier way to know that would be your x values and your y values. The explanatory variable would be your x values. Therefore, we know that as your input. You will enter this as your x value into any type of equation. That equation is going to be the same thing as your linear regression, which looks a little bit like this. I said M. So that's an A, y'all. So my apologies. So that's what the equation looks like. Where y is your response variable. That's going to be your output. It's trying to figure out what's actually being predicted. So I'm going to slide this over just a little bit. And notice how I printed out everything that you may have seen something very similar to this when it's your turn to do your homework. So it wants to know what's the explanatory variable and the response variable. A golfer wants to determine the number of lessons received every year can be used to predict the amount of improvement in his game. I don't play golf. I don't even watch it, but I know plenty of people do. Well, it's using deductive reasoning keywords. Notice how you see the word determine, then you see the word predict. So the explanatory variable would be the number of lessons, right here. Then the predict would be the amount of improvement of your games. So either just an assumption, if you want to actually do a prediction, your improvement in your game, or you improved in your game because you took more and more lessons. Your next example is dealing with linear regression. So hopefully you can see all of this. So it's asking quite a few things. Because this is a multi-step problem, be very careful in reading it. And if you read this, you will have to substitute your values of A, B, C, and D into this problem. Again, it is not multiple choice. I've already given you the answers, but let's figure out how I got these answers. So again, I'm giving you the answers. So one of the things I'm going to do while you're writing these down, or you're depositing, the values that are given, I'm just going to write those off to the side. Let me inch that over just a little bit. So these are what you've seen previously in the first slide of this particular problem. These are the values of x that you're going to substitute into each one. These also represent the different parts of the problem that you actually have to complete. So if you pay close attention, your smallest value for your x's is 8.5. Your largest value for your x values is 12.5. So using deductive reasoning, we're going to say this one is not meaningful. Even though if you actually do substitute it into the equation that I'm going to show you shortly how to get, it's not meaningful because it's too big. Again, your largest one is 12.5. This is 15.5. The same thing goes if something was 7.2. That would be too small, where your smallest value is 8.5. So be careful when they're not meaningful. But now let's figure out actually how to put this in the calculator. So remember, you actually have to go to Stat. You're going to go to Edit. So let me show you. To clear out your list, use your Up key, then Enter for each one that's highlighted. So for your X values, you're going to put those under L1. And your Y values, you're going to put those under L2. So now I'm putting the numbers in. So this may take some time. So I'm trying to go fast so we won't make any mistakes. So if you see any, just ignore me because I'm going to try my best to catch them. Is it 4 or 3? Yeah, too many. Alright, so now I'm going to go to the Y value. So practice is one of the main things to do. Once you get used to using the calculator over and over again, you may notice that it's a little bit easier to put your numbers in. So now I got all my numbers in. I thought I did. Let me make sure. Looks like I made a mistake somewhere. So let me figure out what I did incorrect. So 8.5, 9, 9, 9.5, 10, 10. Wait a minute, wait a minute. 10, 10, 10.5, 10.5. There we go. I found it, y'all. I might be sounding a little bit country. So, voila. Did I find it? Awesome. Okay, so thank you for your patience. I found the mistake. So notice how everything has its own little pair. Next I'm going to hit my Stat key, go over Calculate, go down to your linear regression, hit Enter. Notice how L1 and L2 appear. So if you have an older calculator, you just hit enter. So enter again. And be careful when you write it out. So notice how you have y equals ax plus b. Substitute your values in for a and b. So a is going to be 1.74 because that 9 is going to make that 3 or 4 plus 52.69. And my instructions earlier actually stated that they wanted to round to the nearest hundred. Now we have to graph it. So make sure you write this formula down, or this equation. Because now I'm going to hit the y equal key, hit clear by any chance you have anything in it, and I'm going to type it in. I messed up my x. So I'm going to have 1.74. Again, look at the yellow fingernail polish, hit x plus 52.69, enter. Hit your second key, then y equals, hit enter again. That's to help with your plot. Notice how your graph is on. Using your down arrow key and your right arrow key. You want to go back to the first graph. With the first graph, that's going to be your dot, so you're going to hit enter. Once you hit enter, everything locks in. So go to zoom. Go to zoom stat. Once you hit zoom stat, voila. Now make sure that you actually put this in under Y1. So let's go back to what we had for the previous problem, or the first part of this problem. That is why your graph is this particular one. So you knew it's going to be positive because your coefficient is positive. So that's why you're going to leave B or C. But make sure you be very careful to look at the number of dots above and below each one. So notice how it's dots below this line. There are not that many dots below this line. In fact, there's not any. That's why it's C. Now we're going to use that same equation that we wrote down and substitute our values in. So we're going to have 1.74 times 11.5 plus 52.69. And you can't see it, so let me zoom out for a little bit. That's where we're getting this number from. Then this one, using the same equation, substitute your value of x as 8.0 plus 52.69. Then for part C, notice how it's asking for 15. Well, that's going to be too big. Therefore, it's going to be not meaningful. The reason why it's too big, remember, our largest x value was 12.5. So right now, not meaningful. Then your last part, using the same equation. Notice how I'm doing a hard copy of everything, so you might see some stuff being repetitive. Plus the 52.69. And you have that answer. So be careful with the meaningful and not meaningful. Your next one is coming back to dealing with absolute value. In regards to your absolute value, remember that it's measuring how far away it is from 0. So again, how far away it is from 0. With these particular two numbers that we're using now, let me zoom in so y'all can see it. It's going to be 0.703 and negative 0.09. Notice how your answer choice is C. Negative 0.908 represents a strong correlation because the absolute value of that is greater than the absolute value of 0.70. So here's a side note. Note that negative 0.908 is closer to negative 1 than 0.703 is to positive 1. You may recall in our first example that correlation goes between negative 1 and positive 1. So again, we're looking at which one is closer to a 1. Here we go again with another example dealing with correlation. So let me zoom out. And this is a good time for you to actually pause the video to write some of this down. Just a moment, I'm actually going to put everything in the calculator so you can see it. So hopefully you were able to pause it. So now I'm going to zoom in. Notice how you're saying using your calculators, your x values go under L1, the y values go under L2. Now that you see your numbers, and I've already cleared out my list, for your x values, they go under L1 again. Your y values go under L2. So we have awkward silence here, other than my buttons pressing. Okay, so we got our numbers in. Go to Stat, use your right arrow key, go to Calculate, go down to Linear Regression, hit Enter. Notice how L1 and L2 already show for this particular version of the calculator. Those of you with the older model, just hit Enter. Go down to Calculate, and voila. You see where the 2.374 and 57.45 come from. Now, unlike the previous example dealing with linear correlation, you only rounded to 2 decimal places. This one right here says you're going to round to 3. Now we have to graph it. Hit your Y equal key, hit clear, and put in the actual equation that we wrote down. Notice again, yellow fingernail balls. That's your X. Plus the 57.415. Enter to lock it in. Now hit second, Y equal, enter. You want to make sure that your scatter plot is on. Notice how it's the first one and on is flashing. So hit enter to lock it in. You're going to hit your zoom key. Go down to zoom stat. And there you go. Now looking at this graph, it either can be A or C because both of them are going in the positive direction. Once again, pay close attention to the number of dots below and above the line. So notice how this one right here got one directly below, but somewhere up here. But then you have this one right here, which has that one very, very close. So this is up